So let's just remind you of another technology that I didn't speak about, the transcranial magnetic stimulation, the TMS. So here you see an example, early example of this technology that is being used today both for clinical purposes but a lot for experimental processes, because you can generate through this transcranial magnetic stimulation an electrical field around particular brain region, and so you can activate, not record, like fMRI and EEG record the activity. Here you can induce activity through this magnetic field, and you can induce activity in a large group of cells. It's not a single cell, in a large group of cells, and you can ask what is this region responsible for. So you see here the well-known Professor Oliver Sacks, who wrote many beautiful, very touching books about the brain. For example, The Man Who Mistook His Wife for a Hat, or recently, Musicophilia. He looks at patients in a very compassionate way, brain patients, and look at the patients and look at the disease or at the outcome of the disease in a very unusual, very emotional way, trying to explain the phenomena. And in this case, Oliver Sacks went to Australia, to the lab of Schneider there in Australia, to get a little bit of TMS stimulation. Why? Why he wants TMS stimulation? So he's a very curious person, of course, and one of the issue is whether I can enhance capabilities using this technology, for example. So Oliver Sacks says that he's not a very good painter. He doesn't know to paint very well. So when he looks at cats, he doesn't know to replicate them using visual motor feedback. He doesn't know to copy them. The question is, if I would use this machine to stimulate the frontal lobe here, which is considered to be associative region in the brain, will I become a better painter, so to speak? Can I enhance my capabilities, enhance my cognition? So this was an experiment. There are papers showing yes, maybe, a little bit. Of course, this is a transient thing, so you may stimulate me here for 10 minutes using this magnetic stimulation. Maybe I will be able to do something a little different, because after all, you intervene with some of my networks and I'm doing something else while you stimulate or following my stimulation. Later on, if my synapses are not crystallized and become informed permanently, then I will become again myself as before. So these are issues about stimulating the brain, enhancing cognition. This is an open issue, of course. It is for us to discuss this type of intervention. Just want to highlight a recent book that I edited myself with Henry Markram, who is part of the Human Brain Project. We are part of the Human Brain Project, because this is a very interesting subject, of course. The intervening with the brain non-invasively, this time with electrical stimulation or magnetic stimulation, but you can do it, of course, with chemicals, with mood brighteners, antidepressants, and other drugs that you know for different purposes. And so I think this is for the society to decide. These tools will come, already are here, they will be more and more advanced, and we will have together as a society, not myself as a scientist, we develop tools that the society may decide yes or no to use them, and for what purposes and what are the limits. So I want to end by saying that tools are coming, tools are useful. Sometimes in this case, for example, in the TMS case, this is now being used instead of this bombardment, this convulsive electrical shock, sometimes needed to be used for depressive people where medication is not helpful. Sometimes this is the only way to do it, the big convulsive shock that we are still using today. This is a local shock, if you want to call it, local stimulation of the brain, and this machine already proven itself to be useful for some depressed persons. So it is clinically useful. Also, you can intervene with the brain for many purposes and study the causal relationship between activity or inactivity of this brain using this tool. But whether we want to go and enhance our cognition or not, that's a question. Just before the last personal note, I want to speak about the free will issue, because this is the most fundamental thing about all of us. We feel free. We feel that we can initiate something just by wanting it, willing it. Is it so? What can neuroscience say about this? How free are we? So I want to start with a very, 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 very classical example. The first one that was documented in a very systematic way. So this is many years ago in Vermont, whereby Phineas Gage, very well-known patient, who was a apparently very, very pleasant, interactive, communicative, lovable person. He was worker in some factory, and there was a blow in this factory, something blew up, and a rod went through his brain. This is a reconstruction. Because we have his skull, this is a reconstruction of the rod going through. You see the frontal part of the brain, really a significant injury. He's the most famous patient to have survived severe damage to the brain. He is also the first patient from whom we learned something about the relation between personality and the function of the frontal parts of the brain. So this is Phineas Gage. And these are different reconstructions of the rod. So he went under operations, they took the rod out, and relatively fast, some months after the accident, he went back to work. So he felt strong enough to come back to work. You can read it later on at home. Just want to tell you something you may have known, probably you heard about this in other cases, different cases, that something has changed in his personality, something severe has changed in his personality. He started to be very unpleasant, not communicative, angry, somebody else. So people, his friends said he was no longer Gage. It's not the same person. They could not function with him, but this was a very lovely person before. And you all know that some personalities, especially due to injuries, dementia, Alzheimer, some changes in the brain, this is a severe change in the brain, give rise to a change in personality. I assume that we all tend to agree, but this is a debate, we tend to agree that Phineas Gage could not choose, he could not choose freely to change, to have changed. We all agree that something went into his brain, changed physically, the brain physically, and it's a different person. This we accept. So in his case, he was not free to choose to be a nice person. He was not free. But was he free to choose to be a nice person before? And suddenly he's not free because of this rod? Or are we all not free to choose without all this terrible thing happening to him? That's a question. So let me cite two important people. Thomas Huxley from the Huxley family, Aldous Huxley and others. He said, are we completely defined by the deterministic nature of the physical laws? Are we essentially sophisticated automatons with our conscious feeling and intention tacked on the epiphenomena with no causal power? We cannot really decide willingly, but we are driven as an automata to do what we do. Or do we have some independence in making choices and actions? not completely determined by the known physical laws. That's Thomas Huxley. And Isaac Bashevis Singer, the great Nobelist, and writer, also Nobel laureate, says the greatest gift which humanity has received is free choice. It is true that we are limited in our use of free choice. We are limited. But the little free choice we have is such a great gift and is potentially worth so much that for this itself, life is worthwhile living. So this is the way an artist puts first the realization, which is deep, that free will is limited, maybe completely limited, but he feels that because it's not completely limited, the thing that remains is worthwhile for living. But do we have free will? So the most dramatic and the most important beginning of the research after free will is the work of Benjamin Libet, the well-known experiments about free will. So Benjamin Libet was using EEG on the skull, the non-invasive technology. You record electrical activity emerging from within the brain on the skull. You use EEG that I showed you before. This is a sophisticated EEG with many, many electrodes. You can get different EEGs with less electrodes, so 1, 2, 3, and so forth, but you can record brain activity, and that's what Libet did. A very simple experiment. So he put a person with EEG and asked him to do the following. So the person was looking at the screen as you look now, and in this screen there was this little ball moving, and you as experimentalist, the one who is doing the experiment, the only thing you have to do is absolutely freely. Nobody tells you what, nobody tells you when, but when you decide your own decision, you press a button on your own choice. So you look at this, and at some point, let's say now, independently, whatever you want, you press a lever. You press a lever at any time you want. The only thing you have to remember is at what time you decided, when did you decided freely to press. So let's say I'm doing the experiment, I press. I remember the red spot was on 15. I look at it again, I press. I remember it was 55. That's all. Very simple experiment. So now, the EEG. So at the same time when you do this free pressing, free choice, Libet was looking at your brain. So this is what one sees in your brain before you start to press. So you press here. This is time, let's call it 0. At time 0, you press. Physically, you press. Here. You can see the EEG, you can see the signal in your brain building up. Building up, building up, building up, building up. This is called readiness potential. You become ready to press. But you didn't press yet. You only pressed here. Okay. So this is the time of movement onset. This is the time when you start to press. 0 time. Now the question is, at what time did you consciously decided? Because you know exactly when you decided. It was when it was 15 or when it was 45. So you tell us, the experimentalists, later, when did you decide? Apparently you decided here. This is when you felt the will to move. Okay? You felt the will to move several hundred milliseconds before you actually moved. Okay, that's fine. The issue is that your brain activity started to grow. You can see that the brain is already planning the movement. The brain is planning the movement here. Maybe 2 seconds prior to your decision as you report it. So this is amazing, no? You are aware of the decision. You decide to press here. There is a gap between your decision and the actual movement, which is understandable. Between the decision and the movement, of course, there is time until the activation of the muscles and all this network activity. But what is all this period? You are not aware of it. Your brain is already preparing to move. Not only that, but today we know that we can use this signal to know if you are going to move left or right. We know to say something much before you are aware of it. So who decides? Is it you or is it your brain? This is your brain. The subconscious part of your brain is active already. You cannot report on that. You can report only here that you decided. Many people take this as a signature of the fact that you do not have free will. Because your free will, your decision, is made here in terms of being aware of it, but your brain started to be active 2 seconds before, and you are not aware of it. So can I say that I'm free if you, Libet, can tell me what I'm going to do, and I am not aware of it yet? So you from the outside can look at my brain and know from this readiness potential that it's going to happen. And not only you know when it's going to happen, and you even know whether it's going to move to the right or to the left, your finger. So the experimentalist, Libet, can tell something that I'm not aware of. So what kind of free will do I have if I'm not aware of it, if I'm not conscious of it? This is amazing. This is difficult. So you move the finger here. You report here that I decided, but the EEG signal, readiness potential, starts here. So there is a gap between the brain working and you becoming aware of it. This is a puzzle. Libet findings have been widely taken to show that since our brain has already started preparing to flex the wrist before we even became aware of our intention to flex it, our supposedly free will is not free at all. Rather, our brain has decided for us and has started to a causal chain leading to a finger bending before we became aware of it, our decision. Thus, our will appears determined and causally irrelevant. I feel that I decide causally to move my hand, but this was already decided before I am aware of it. Furthermore, there are new results. And this is one of them from a science paper some 4 years ago, whereby patients that undergo brain surgery are implanted with specific electrodes in the open skull. So this is more direct to this region or to this region or to this motor region. And you can stimulate locally before they go to the operation and see some amazing phenomena. For example, if you take this particular region here and you stimulate it with low intensity with your electrodes here, here, or here, the patients, the reports, I felt the desire to lick my lips. So he feels that he wants, that he wills to lick his lip. So he is consciously reporting that he wants to lick his lip. When you stimulate here, he doesn't lick his lip. So he doesn't move his tongue. But he feels that he wants it. So you activated his will. He says, he reports, I felt I want to lick my lip. This is for small stimulation here. For higher stimulation, he reports, I moved my mouth I talked. What did I say? So you activate this region more strongly. He reports that he felt that there was a movement, but he's not aware of what he said. So you activated his brain, but he did not decide on this. He does not say, I decided to move my lips. My lips moved. Somebody moved them. How? I don't know. What did I say? In another region here, the premotor regions here, you can stimulate strongly. The hand will move. The hand will move. And he's not aware of it. So if he doesn't see the hand will move. The hand will move. Just by stimulation, he's not aware of it. So you can intervene with the brain in a very specific region, in a very specific way, strong or weak stimulation, and suddenly you will, and suddenly something happened and you ask what happened. It's not me. Who moved my hand? Who moved my lips? You can see slowly, the issue of the machine. I just want to summarize this part by some beautiful phrases by Professor Wolf Singer. He is from the Max Planck Institute in Frankfurt, a very well-known researcher, already starting in 2004 to say, crime itself should be taken as evidence of brain abnormality. So the fact that I did a crime, if I am a deterministic in a sense that I don't have free will, the fact that I did a crime is not my choice. It's my brain. So something about my brain is criminal. It's not me, it's my brain. Even if no abnormalities can be found in the brain, criminals should be treated as incapable of having acted otherwise. So I cross in red light. It's not my choice. It's the brain. Most of what we do at the subconscious level, is at the subconscious level. So we are not aware of all the elements that makes us behave in a certain way. So this readiness potential is unconscious, but it is dictating what I will do later on, and I'm not aware of it. Free will is an illusion. We need to continue to assign value to our behavior, essentially for organizing society. So even if we come to the decision, which is slowly creeping in, that we are not really free in the most strict sense, and I want to say that there are a lot of discussions about that. Philosophers, neuroscientists, ethicists. It's not clear-cut as yet. The question is, what is the definition of free will? When you say completely free or not free, there is the issue of choosing and picking. There are many aspects of free will. But even if we shall come to the decision based on scientific results that we are not free in the classical sense, whatever it means, still, we may continue to behave in the same way. First, because we need to feel free. So you can tell me as much as you want that I'm not free. I insist, so to speak. My brain insists on generating this illusion of being free. That's one aspect. The other aspect that in terms of ethics, because I drive in red light, because I am a criminal, you may continue to put me in jail, not because I decided to be a criminal, but because I am dangerous to you. So up until now, the issue of free will, and let me just summarize by final words.